Welcome to Understanding Mathematics, and today I'm going to be going over some examples involving limits, specifically limits that approach asymptotes. Now, limits are one of those things that they're pretty confusing and strange if you haven't really had very much experience with them. So if you're taking first semester calculus and you're probably learning limits, and some of them are easy, but there's another handful of them that are really difficult and you just don't understand, this video is for you. Now, I'm going to start with an example that has two ways to solve. You can use a graphical approach, which I prefer, or you can use an algebraic approach. Both work perfectly fine. Just sometimes if you're having a test, you're not allowed a calculator, and so you can't graph it on your graphing calculator. You'd have to use the algebraic method. So we'll cover the algebraic method first. It's important to know both. I think it's probably a little bit more important to know the algebraic method just because a lot of teachers don't allow you to use calculators. So let's get started. The limit is approaching 5. And we have our function, x squared plus 5x plus 6, all divided by x minus 5. Now, one thing I will suggest is you should try to factor the top, because every now and then you'll get an example where this will factor out and one of the factors will be x minus 5 on top. And so you can cross that out with this x minus 5 on the bottom, and then it's just a really simple linear problem. But that doesn't happen very often in difficult test problems. So you need to know this algebraic approach. So I'm assuming you know the definition of a limit. If not, I'll just explain anyway. So you need your left-handed side limit to be equal to the right-handed side. And since we're dealing with an asymptote, we need to find where the asymptote is, because that's going to dictate a lot of what this problem is going to behave like. So x minus 5 at the bottom, that will define where the asymptote is. X minus 5 equals 0. And we can solve for that, simple algebra, x equals 5. So we have an asymptote at x equals 5. That means we need everything on the left of 5 to be approaching the same direction that everything on the right of 5 is approaching. If not, the limit doesn't exist. Okay, so let's start with the algebraic method. And basically for this, all you do is plug in numbers. It's that simple, I promise. So what's smaller than 5, 4, 3, 2, 1, 0? I suggest using an easy number so that your math is simple. You don't want to waste time on these exams. So let's say x equals 0. You're going to have 0 squared plus 0 plus 6 divided by negative 5. Now this will reduce to 6 over negative 5. It's really bad 6, sorry about that. Okay. Now it doesn't really matter what this number is. All that matters is its sign, positive or negative. This one happens to be negative. And that's important. So if our left-hand limit is negative, that's all this means. It's approaching negative infinity. If our right-hand side also approaches negative infinity, then we know the limit exists, and the limit is negative infinity. But if it's positive, then the limit does not exist, and that's important to know. And then if this is like a homework assignment, you could double check your work by graphing it and seeing how that behaves. I'll show you how to do that in a second after we do the right hand limit. So for the right hand limit, we need to pick something that's larger than 5. 6, 7, 8, 9, 10. It doesn't really matter. We'll just use 6. So when x equals 6, we'll have 36. 6 squared is 36. Plus 6 times 5, 30. Plus 6 all over x minus 5, 6 minus 5. Now, if you're taking a test and you don't have a calculator and you don't want to waste your time doing this petty algebra, honestly, the truth is you don't have to do this algebra. All that matters is the sign. So you can look at this and you can say, oh, well, this is 62, but it doesn't matter really. What matters is the sign. And they're all positive numbers, so it's just going to be a positive on top. Then you look at the bottom, 6 minus 5, that's also positive. So you know that this is a positive number. And what this means is that the right-hand limit is approaching negative infinity. So you have one limit that's positive infinity, one limit that's negative infinity. What does this mean? This means our limit does not exist. That's really ugly, but yeah, you get the idea. It does not exist. Now I'll show you the graphical approach, which is a lot cleaner, a lot simpler, a lot less math. Some people might like this. So this is the function x squared plus 5x plus 6 divided by x minus 5. And you can see it approaches an asymptote along this middle line. And that's our asymptote, x equals 5. And so we can see from the left side, it's going down negative just forever to negative infinity. The right hand we can see is going positive infinity. So that's how you can see really simply. If you don't want to do the algebra and it's a homework assignment, and you're allowed to do it graphically, because if they say show your work, you should probably do it algebraically, but it's a good way to correct your work and to see if your algebra is right. Just see, oh, this one's going up, this one's going down. Limit does not exist. They approach different things. So here's our next example. The limit as x approaches negative 2, the function is x squared plus 4x plus 3x plus 2. Now at this point I've already showed you how to do this type of problem. This type of problem is very similar to the one we just did. So I recommend pausing the video and trying to figure out yourself, does the limit exist? If so, what does it approach? So now I'm going to start solving the problem. It should be a very similar approach to last problem. Hopefully we get the correct answer. How do we know if we got the correct answer? Well, we'll check graphically to see if it makes sense. Okay, so let's start. We need to find the asymptote first. That's the first thing to do. If there's a denominator, you always find the asymptote. So set the denominator to 0, and you'll find that the asymptote is almost always the same as what you're approaching. That's a pretty good way to see if you're making good progress on a question. That's how you know you're doing it correctly so far. The asymptote is always what x is approaching. So now let's start trying to solve this algebraically. So we need something from the left-hand side of negative 2. I'm just going to do negative 3. So x equals negative 3. Negative 3 squared is 9. Minus 12. Plus 3. All over negative 3 plus 2, negative 1. Now if you notice here, and this is a 9. I'm going to redo this. 9 looks like 4. Now if you notice, the numerator ends up being 0. And so what happens when the numerator is 0 is you can't use that value. You need to use something else. You should try negative 4, negative 5. This happens sometimes. It doesn't mean you did it wrong. This just means you need to try a different number. So negative 3 didn't work. Okay, well let's try negative 4. So now we have negative 4 squared, that's 16. Negative 4 times positive 4, it's negative 16. And we're just plugging it in back to this main function, by the way. It should be clear, but minus 16 and then plus 3. All over x plus 2. And so what we'll get is these two cancel out, and you get 3 over negative 2. What's the most important part of this? That you have a negative number. Now let's do from the right hand side. Anything that's greater than negative 2. An easy one is 0. Always do 0 for whichever one of your limits it is. Whether it's right or left, it depends on what your asymptote is. Always have a 0 in there. It makes your algebra so easy. Next is 0, x squared, that's 0, plus 4x, that's also 0, plus 3. Okay, 3 on top. x plus 2, that's just going to be 2, 3/2. So what's important about this is that they're both positive. So we have a positive limit here. So this, the right-hand side approaches positive infinity, and the left-hand side, negative infinity. Well, how do we know if we did this correctly? And so looking at the graph, we see one's going up, one's going down. It's that simple. If you have a graphing calculator, these problems become so simple. It's just a matter of understanding how to read the graphs, interpret the data. And that should just about wrap it up. I hope that this helped out with your understanding of limits, and I hope that you do well in your exams. See you next time.